Petronas. My question is directed to the professor, right? The multi-phase flow meter. Right? We in Petronas certainly have installed quite a number of multi-phase flow meter, and we found that they not so working so good. Yeah? But the problem is that the meter is only good if you have the data to start off is good. You know that with the subsurface data you can't really predict until you produce. So many times we purchase multi-phase flow meter. They end up outside of this operating envelope, right? To make meaningful measurement. So how do you think your virtual multi-phase flow meter can help in this scenario?
Yes. Well, it depends. The one I presented is, after all, similar in principle to the ones you have been using. So you get information and you have to derive flow rates from information. So the main advantage apparently is only a matter of cost, which is not negligible. It's better to buy something which doesn't work and cost not much than spending a lot of money for something which doesn't work. But there is something more which I should add, and it is something which I don't know the other producers how serious they are in studying the behavior of their flow meter. But the example which I gave to you is a flow meter which has been constructed, and exactly as it has been tested in the lab, it goes to the field. We don't know yet the results of the field because this is a very recent installation. We started last year, we are going to end beginning of this year. We made the tests exactly the same conditions which the meter is going to find in the field. Then I'm almost sure we will have to tune, and there are different methods to tune. But in principle, it is not different from what you have. It's only a matter of being able to know and to use better modeling and to have a lab to test the system. The other system which I've been showing, the wet gas meter, which now applies also, say, to the oil field, is more serious, is more objective, is more accurate, and is more expensive. So it is a matter. No, it's not more expensive than the others, but it is more expensive than the one we presented. So what is the message I try to give is, listen, if you have to buy a multi-phase flow meter, in particular for subsea applications, which are probably gone for some years, but don't spend a lot of money. You can have the same information at a much, much reduced cost.
I'd like to just interject that I noticed he mentioned a install base, and based on our research, that install base is probably double what he had up there, but I can't get into too much specifics. We try to sell our studies, but I'm aware that early on there was some challenges with some of those units, and I know you guys were one of the earlier adopters, but I basically have gotten the impression from some of the owner-operators we've talked to and some of the suppliers that certainly the performance has improved. And I'd like to hear from Greg if he wants to comment at all and any of his thoughts. Or.
Yeah, I mean, performance of instruments in general has improved over years, and that's, part of the problem with multi-phase flow meters is when instruments weren't as accurate, and you're trying to take them and make this device more accurate from where it is. And over the course of time, as you say, you can get to a level of accuracy improvement in a lab that nobody believes because it's that good and the instruments are that much better. So it's more or less, are you willing to try new devices again? And if you're willing to try new devices again, part of it comes not just with better performance, but some of the things that Dave talked about was they're going to be smarter, they're going to give you more data. That data into a system or a supervisory software system will allow to interpret a little better and then optimize your well performance, optimize the meter based on what happens, which is there. So the smart instrument piece continues to evolve, and I can say from an ABB side, and I know we can probably say from a Yokogawa side, and every other major manufacturer is, that's an area we're constantly evolving in, working on diagnostics, and not just diagnostics for meter, the instrument needs maintenance, diagnostics on this is what's happening in the application, right? There's gas bubbles, there's coatings, there's pipeline integrity issues. So you can use that meter with all the smart data to operate a little bit more, and then use the modeling and other pieces to optimize your flow measure.
I think we had a question here from the audience.
Yeah, this is for David. So I'm in the IoT software space and building vertical solutions, and your map of a new way to connect on the left is actually kind of right in our wheelhouse and what we're doing. However, I was kind of, in a lot of the sessions I've had and spent a lot of time with Tim over the last 12 months, there's a lot of valuable data in the control side that exists already. And so I guess what I'm wondering is, due to the fact that most of the fields will have systems and control systems that have been in place and installed at different times over the last 30 years, sometimes they're interconnected, sometimes they're not interconnected. What do you see as the value, especially with your long time at BP, what do you see as the value to be able to bring both the monitoring data through the kind of new generation connectivity you're talking about, but also be able to then siphon off some of the control data at the same time?
Yeah, so definitely, because you have to put these readings into context. And so a lot of the monitoring stuff is the context setting, but the control stuff is still there. So typically what you would do is you would restrict your SCADA stuff to critical control loops, but not all this new monitoring stuff. But then that stuff would be historized and then pushed into an analytics system. So the end point is the same for both data streams, but you would just treat it a little differently just to get her out of that cost and complexity issue. But yeah, you definitely need both.
And you see a lot of value in that.
Oh, without question.
Anybody else want to? Okay. Any other questions folks may have? And if not, I'd like to ask Penny a question or two. And perhaps Sharul can answer this as well. But based on this project and perhaps other ones, are you seeing either specifically to this project or others that you've worked on the kind of time and cost savings as well as any other beneficial things? And how would you sort of characterize those? And because our research at ARC is certainly indicating a continued adoption of wireless technologies, pretty much primarily in the monitoring area. Controls a little bit of going to be a laggard for a while, I think, but we're seeing a lot of positive signs, and I'd just be curious as to what some of your either specific experiences to this project or just in general might want to share.
Okay, thank you. I think it's a very good question. In general, we really see wireless. You look at the whole IoT discussion, wireless really bring another new area of the technology to the field, which is not actually used in some way in oil and gas area, but not extensively. There are many limitations. However, the technology getting more mature and also getting more standardized. Especially at least because I'm champion for IC100.MA technology. So they are very IoT type of wireless network is designed for this industry applications. It has gone through several years and with a lot of professionals in this area, over 400 different professionals built into the IC100. So if we look at the technology itself, why there are so many people in industry are so interested in building a wireless technology for industrial automation, there is a reason. So the technology can be more reliable. Why has to be more reliable? So we talk about the IoT and the IoT. The gas detection is one of the very good example of it. you have very smart the field device, as Greg also mentioned, that there are more field devices getting smart. You have data crowd on the back, as Dave mentioned. Then what do you need? You do need very reliable communication from the field to the data center. Wireless has played a very important role in here. If we go back to one fundamental we have, you think about all our humans are wireless. When we was born, when we talk, it's all wireless. So we've been using the same thing, we've been enjoying the flexibility. This is why I see wireless technology really bring a great flexibility. And also, right now you see we're using for some of the safety applications. That is for enhancement. We never said that will replace wired, but there are a lot of applications, a lot of new sensors, smart sensor, or even not very smart sensor can be used for the field enhancement. That is absolutely coming. That's why we bring Shahu in here to give a presentation on. It's sort of more eye-opening in the field that has been used for, because the gas detector in his example is a Cell 2 certified gas detector. So things is coming.
Great. Sure, absolutely.
You know, the one thing with the data and the smart instruments, you know, from a manufacturing point of view or a vendor, you know, we were equipping devices with all that information that you can get the output. But what David talked about is you need to change a holistic approach, and especially in the oil and gas industry, of understanding what to do with that data and how to use that data. The data's there, but I can say the oil and gas industry is very slow to adopt changes that are there, and I've been driving my pickup truck out, you know, for years to go service these devices, and you can do remote calibration verification, remote monitoring of devices, and it's going to be a change in the mindset to be able to adopt that and bring that on. So I would say the good thing from a vendor point of view, and I don't want to speak for you, Galwood, I can pretty much say the same thing, is we're equipping devices with it. So what's being installed today has that intelligence in it. And as the market evolves and the industry evolves, they'll be able to use wireless capabilities, other devices, to access more of that information.
And based on our discussions with some of the owner-operators, we see that a lot of times they've had a success in one little area of the plant, for example, and they'll look at other applications. And in many cases, they'll find one or two that even some of the suppliers didn't necessarily think of. So that's sort of an exciting thing, is that sort of momentum builds additional momentum. So any additional comments there?
At $110 a barrel, no one cared about saving money. At $30 a barrel, everybody's very interested in this new approach now, because they can't afford to do it the old way.
Right, and if you were able to hear the ExxonMobil keynotes in the earlier sessions yesterday, and the think differently and we can no longer keep doing things is definitely going to be a mantra that you're going to be seeing. And I think that's the same type of mantra that other industries have already adopted well before. Discrete industries, automotive and aerospace in many cases are a decade or two ahead of some of the process markets, which are, you know, for mainly right reasons, are a little bit more slow to adopt some new technologies. Just want to open it up again to anybody in the audience that might have a question on their mind. Okay. Well, I'd like to go back one more time to, we got about 5.5 or 6 minutes or so, if not more. And I'd like to ask Greg, because I know we've done a couple of different studies on multi-phase flow metering, and all due respect to the professor, I do think that more and more of these do work. And I'd be interested later on afterwards to see when you had put those meters in, and whether it was AGAR or one of those other units that I'm aware of that in my mind was, when I look at all the technologies out there, they were very much, I think, kind of old technology and maybe not. So maybe, I don't know if it was a timing issue. If you told me it was just yesterday, that might be, maybe make me eat my words, but I wouldn't be surprised if that was 5 or more years ago. Then perhaps maybe you have gotten so burned that you're a little bit hesitant to try it again. But I do think that some of the technology really has made some good strides, and the owners, the suppliers are continuing to make, and some of them are making investments in their own testing facilities to try to show the customers that they can validate the performance. So and there's other organizations like TUV, NEL, and Southwest Research Institute, and some other ones that are also acting as sort of independent testing facilities. So that, I think that's going to continue to help increase adoption. The low oil prices are going to maybe slow that adoption down a little bit, but I think long term there's a lot of value in employing those devices. So just to go back, Greg, based on my research, there wasn't too many suppliers that I saw that could do a non-gamma solution and handle those high gas volume fractions. So when I saw your solution, I was very much impressed, and I'd like to learn more about. I got a little bit from the professor of some of that technologies, but I'm just curious as to. Because I almost looked at that as almost a game changer in terms of being able to handle those wet gas situations in a non-gamma solution.
Yeah, I mean, for offshore applications, it fits perfect for the high gas volume fractions. Onshore is a little bit different because of the slugs that exist there and the other pieces that happen, and that's an area where we're collaborating to look at do some testing onshore. So it's really two different worlds from the multi-phase side. But the product from an offshore side is really robust. What part of the attracted ABB to TEA was one, the non-gamma source, which the feedback we get from a lot of customers is it's very difficult to get operators and to transport them around. So what we looked at was how do we do this in a manner that it's a pretty simple way to maintain, because if it's on a platform somewhere, it's a lot of money if something happens to go wrong there. Since you're just using basic pressure transmitters and DP transmitters as well, I can have the ability to do that. The remote monitoring capabilities is I can check the device, the health, the status of that device from outside the environment. I don't have to incur all those costs to be able to go there. So that's the one area that attracted us, from an ABB point of view. We're strong in the oil and gas segment and strong in the offshore oil and gas segment on one side, and we're investigating opportunities on what we can do with the technology to do some testing onshore and allow us to leverage some of our other strength, which we do with flow computers and RTUs, to provide more of a complete package for those customers. But the TEA solution, is the basic fundamentals of it is part of what we want to talk about, and I heard it from Exxon from when Sandy talked about it, is standardization of pieces sets here, and multi-phase has always been this, black magic, this is what it is world, and the solution we looked at and what attracted us, to this is it's standard differential pressure, so it's very easy, it's complex, everybody can operate a pressure transmitter, troubleshoot a pressure transmitter, or recalibrate them in the field, and you don't have to take them back or send them and deal with all the issues that come with the radioactive resources there.
I just wanted to add an extra information. Tim, you were mentioning the possibility of checking the instruments in an independent laboratory. The meter which is now sold by ABB was tested at NEL over 10 years ago. And when we finished this test, we tried to ask the guy over there how was going with our instrument. And the only answer he gave to us has been, listen guys, the first time, our meter was the last to be tested at NEL in that period. This is the first time that I had to change the scale on which I represent the errors by one order of magnitude. The maximum was 100%, with us became 10%, which was encouraging. But again, there was a trick. The same instrument, before going there, was tested carefully in our lab. I do not know, because I think this is, probably I can find it written somewhere. I'm not sure that other flow meters on the market have been tested in the lab before going to the field. I know for sure that at least one producer has got a good lab. I don't know about the others, but you know, having a good lab, working fine, producing good data is a matter of years of experience. You don't start today and within 1 year you have a good lab. I've been running this lab for the last 40 years. And all the times I go to the lab, I learn something new every day. So it is a matter of experience. Producing good data, I can tell another story. I am an academic. I still publishing at a good level. I can tell you 90% of publication contain wrong data. 90%. It is incredible the quantity of bad data you can find around.
Okay, what I'd like to do before we make a final wrap-up is to sort of give Penny and then Greg sort of just a few minutes just to kind of make a, you know, what would you, if you were going to sort of sum up, you know, in a minute or two less, what would you like the audience to take away from this sort of discussion, if you would?
Their technology is ready, so don't feel afraid to try it. Trying IC100, that is real technology that built for industrial automation, especially for process automation. So if you are, even have a DAO, or if you have any willing, and we're willing to help you. This is IC100 Wireless Compliant Institution. This institution is built to help you adopting the technology. Thank you.
Thanks, Ben.
And the one thing I would maybe sum up with is, you know, the Internet of Technologies, or Internet of Things, is happening, okay, and it's going to evolve in that way. From an ABB point of view, we add 2 other pieces to it. It's not just the Internet of Things, it's the Internet of Things, people, and services. Because you can have your devices, but if you cannot utilize the information, or the people can't interpret that information, and then provide services or capabilities to be able to do that, it means nothing that I have all this data that's locked in there. And it's you know, as I said, you know, try some things. It's in the past, it was very difficult to understand what that data was. Instruments are smarter. The way we can provide the output and what it can do for remediation or what happens, I think you'll be very impressed on how easy it is to take some of that data and interpret it. But the caution I do have is, you can also be paralyzed by the data. So, you know, you have to understand what to use, what's valuable, and how it can help you improve your process, which is ultimately how does it lower your overall